Okay. Good morning students. This is SOBHA, Physics PGT. Now I would like to explain about the concept of refraction in ray optics. So here ray optics. It will appear whenever the pencil moves from air to water. At the separation of the medium, we have to observe a small bending. So this is due to refraction. This is due to refraction. So why it happens? Means refraction means this is the separation of the medium. Whenever that light ray strikes, on the separation of the medium, means whenever the light ray travels from one medium to another medium. So this is medium 1 and this is medium 2. So here the light ray PO, whenever the light ray travels from one medium to another medium, at the separation of the medium, the light ray bends. So this property is known as refraction. This property is known as refraction. So this is the light ray. Whenever the light ray travels from one medium to another medium, then the light ray at the separation of the medium, the light ray bends. So this property is known as refraction. So let us draw a normal on that. Then what will happen means, so this is the normal, N dash be the normal, PO be the incident ray and OQ be the refracted ray. So here the angle between normal to incident ray is known as angle of incidence I, and the angle between normal to refracted ray is known as angle of refraction R. So here why it will happen means, whenever the light ray travel from one medium to another medium, then the wavelengths are varies, then the velocities are also varies. So that's why it has a small bending at the separation of the medium. So here, suppose for example, it is air medium, it is water medium. So air medium is nothing but the rarer medium. How we can say that air medium is rarer medium means, the speed of light in air is more compared to speed of light in water. So that's why, and in which medium the speed of light is more, so that is nothing but rarer medium, and which medium the speed of light is less, that is nothing but denser medium. So it will act as a rarer medium and it will act as a denser medium. So whenever the light ray travels from rarer medium to denser medium, then the light ray moves towards the normal. So that's why in this case, angle of incidence is greater than the angle of refraction. Suppose for example, we have to take, suppose whenever the light ray travel from denser medium to rarer medium, what will happen? We have to observe. So this is the medium 1 and this is medium 2. It is air medium and it is then the water medium. So here, suppose for example, this is the light ray, incident ray. Here PO be the the refracted ray moves away from the normal. So that's why here in this case what will happen? In this case R is greater than I. R is greater than I. So this phenomenon is nothing but refraction. What is refraction means? Whenever the light ray travels from one medium to another medium, at the separation of the medium, the light ray bends. This property is known as refraction. Okay. So next one is laws of refraction. So what are the laws of refraction? We have to observe. So next one is laws of refraction. So what are the laws of refraction? We have two laws of refractions. One is, here see once, angle of incidence I, angle of refraction R, and the normal all are in the same plane. All are in the same plane. So this is the first law of refraction. So what is the first law of refraction? Angle of incidence I, angle of refraction R, and normal all are in the same plane. All are in same plane. So this is the first law of refraction. So what is the second law of refraction? Second law of refraction means, okay, what is the second law of refraction means? So this is angle of incidence I, this is angle of refraction R. The ratio between sine angle of incidence to sine angle of refraction. So that is nothing but sine angle of incidence, that is nothing but sine I, and the sine angle of refraction, so that is nothing but sine R. The ratio between sine angle of incidence to sine angle of refraction is constant. So this is the second law of refraction. So what are the two laws of refractions? One is angle of incidence and angle of refraction, and normal all are in the same plane. So this is the first law of refraction, and the second law of refraction is sine angle of incidence. The ratio between sine angle of incidence to sine angle of refraction is constant. So these are the two laws of refractions. So laws of refraction means, first law of refraction, what is first law of refraction? Angle of incidence I and angle of refraction R, and normal all are in the same plane. So this is the first law of refraction, and second law of refraction is the ratio between the sine angle of incidence to sine angle of refraction is constant. So that is nothing but sin I by sin R is equals to constant. So what is that constant means? That constant is refractive index. Refractive index. So it is represented by the letter mu on n. Mu on n. So what is refractive index? Let us see what is refractive index. So refractive index is a kind of property. It is a kind of property how the rays are easily traveling to that medium. How the light rays are easily traveling to that medium. So it tells us about how easily the rays are traveling to that medium. So this is nothing but refractive index. So refractive index is a kind of property? It tells us about how easily the light rays are traveling to that medium. So this is nothing but refractive index. So okay, according to the definition, according to the definition, what is refractive index means? Refractive index. So according to the definition, the ratio between speed of light in vacuum to speed of light in medium is nothing but refractive index. So here refractive index is represented by the letter mu. So according to the definition, what is mu? The ratio between speed of light in vacuum, speed of light in vacuum to speed of light in medium, speed of light in vacuum to speed of light in medium. So this is nothing but refractive index. So refractive index is a ratio. So that's why it has no units. It has no units. So suppose for example, mu is equals to speed of light in vacuum is c, that is nothing but 3 into 10 power 8 meter per second, we know that. And speed of light in medium is v1. Suppose for example, speed of light in medium, if it is water or glass or anyone. So c by v1 is the refractive index mu. Okay, suppose for example, what is the, let us consider air medium and water medium. So in air medium the velocity is v1, in water medium the velocity is v2. So then what is the refractive indices? Refractive index of the air medium is mu1 and the refractive index of the water medium is mu2. Suppose we have to take, suppose this is the separation of the medium and this is air medium and it is water medium. So here in air medium the refractive index is mu1, in water medium the refractive index is mu2, and the speed of light in air is v1 and the speed of light in water is v2. Then suppose for example we have to take a air medium. Air medium means then the refractive index is mu1 and the velocity is v1. So it can be written as mu1 is equals to c by v1. In water medium, mu2 is equals to, refractive index is mu2 and the velocity is c, velocity is v2. So that's why it can be written as c by v2. So here mu1 is equals to c by v1 and mu2 is equals to c by v2. So what is the ratio? mu1 by mu2 is equals to, mu1 by mu2 is equals to c by v1 by c by v2. So from that mu1 by mu2 is equals to c by v1, reciprocal of this v2 by c, c get cancelled, then mu1 by mu2 is equals to v2 by v1, v2 by v1. Okay, so mu1 by mu2 is equals to v2 by v1. What is Snell's law? Snell's law is nothing but second law of refraction. The ratio between sine angle of incidence to sine angle of refraction is constant. It is invented by Snell. So that's why it is also known as Snell's law. So Snell's law means second law of refraction. So according to Snell's law, sin I by sin r is equals to of light. So refractive index is more, then the speed of light is less. If the refractive index is less, then the speed of light is more. So this is the relation between refractive index and velocities. So, okay, next one is okay. So according to Snell's law, sin I by sin R is equals to constant. That constant is nothing but refractive index. Refractive index. So mu21 is represented as refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. So mu12 is represented as refractive index of first medium with respect to second medium. So here, so see once refractive index of second medium with respect to first medium. From that, sin I by sin R is equals to mu2 by mu1. Mu2 by mu1. So from this equation, mu1 sin I is equals to mu2 sin R. In some problems, in some cases, it will be n1. n1 sin I is equals to n2 sin R. In some textbooks, why? Because refractive index is represented as mu or n. So that's why in some textbooks, n1 sin I is equals to n2 sin R. n1 and n2 be the refractive indices of that medium. So this is nothing but Snell's law. This is nothing but Snell's law. So what is Snell's law means? The ratio between sine angle of incidence to sine angle of refraction is constant. That constant is nothing but the refractive index. Here mu21 represented as a refractive index of second medium with respect to first medium. So it can be written as mu2 by mu1. So from that cross multiplication, mu1 sin I is equals to mu2 sin R. In some textbooks, refractive index is represented by the letter n1 and n2. So that's why okay, the next topic is total internal reflection. Total internal reflection. So, first of all, we have to learn what is critical angle. So, what is critical angle means here critical angle means suppose for example this is the separation of the medium. Let us consider one of the objects. The light rays are coming from this object. So this is medium 2. For example, this is medium 1. So this is a rarer medium and this is denser medium. So here what will happen means, suppose let us consider one of the light ray. So whenever the light ray strikes on the separation of the medium, the light ray travels from one medium to another medium, no? So that's why it gets refraction. OP be the incident ray, OP be the incident ray, and PQ be the refracted ray. So this is the normal. Let us draw a normal. So this is the angle between normal to incident ray is known as angle of incidence I, and the angle between normal to refracted ray is known as angle of refraction R. And N dash be the normal. So here the light ray travels from denser medium to rarer medium. So that's why what will happen here? The refracted ray moves away from the normal. This is normal, no? So that's why the refracted ray moves away from the normal. Okay, let us consider another light ray. Let us consider another light ray. So this is nothing but OS. So this is the separation of the medium. So this is the separation of the medium. This is the separation of the medium. So here again the light ray travels from denser medium to rarer medium. So that's why the light ray bends away from the normal. So let us draw a normal here. So this is angle of incidence I. Here we are increasing the angle of incidence. So this is the angle of refraction R. Again we have to increase the angle of incidence. What will happen means, again we have to increase the angle of incidence. What will happen means, after refraction the refracted ray grazes over the surface. The refracted ray grazes over the surface. So here again we have to draw a normal. So this is the angle of incidence I, and it is the angle of refraction R. So here the angle is 90 degrees. So at which angle of incidence the refracted ray gets 90 degrees. So that angle of incidence is known as critical angle. Critical angle means at which angle of incidence the refracted angle is 90 degrees. So that angle of incidence is known as critical angle. So here the angle of refraction is 90 degrees. Then the angle of incidence is also known as critical angle. Then the angle of incidence is known as critical angle. It is represented by the letter C. It is represented by the letter C. So here I is equals to C when R is 90 degrees. Again we have to increase the angle of incidence. Again we have to increase the angle of incidence. What will happen means, it gets internal reflection. It gets internal reflection. Internal reflection. So there is no refraction. So this phenomenon is known as total internal reflection. That is the normal. So so whenever the light ray travels from denser medium to rarer medium, if the angle of incidence is more than the critical angle, it gets internal reflection. So this phenomenon is known as total internal reflection. So what is total internal reflection means? If the angle of incidence is, so this is the angle of incidence. So here this is the angle of incidence. If the angle of incidence is reflection. So this phenomenon is known as total internal reflection. So here this is the total internal, this is the phenomenon is known as total internal reflection. So here what is the relation between refractive index and critical angle? Let us see. So what is the relation between refractive index and critical angle? So the relation between refractive index mu and critical angle C. Okay. So according to Snell's law, what is Snell's law? According to Snell's law, sin I by sin R is equals to mu 2 by mu 1. So here sin I by sin R is equals to mu 2 by mu 1. So from that equation, mu 1 sin I is equals to mu 2 sin R. Mu 2 sin R. So here, what is critical angle? If the angle of refraction is 90 degrees, if R is 90 degrees, then the angle of incidence I is equals to critical angle. We know that. At which angle of incidence the refracted angle is 90 degrees, that angle of incidence is known as critical angle. So here, from that, mu 1 I is equals to C, no? So sin C is equals to mu 2 sin, what is the R? 90 degrees. So from that, mu 1 sin C is equals to mu 2. So mu 1 sin C is equals to mu 2. Why? Because sin 90. What is the value of sin 90? Sin 90 is 1. So that's why mu 1 sin C is equals to. So mu 1 sin C is equals to mu 2. So here the light ray travels from denser medium to rarer medium. Denser medium to rarer medium. So here this is the denser medium and it is the rarer medium. So for example, here mu 1 and mu 2. Refractive indices are mu 1 and mu 2. So here, so what will happen means, whenever the light ray travels from denser medium to rarer medium, then what will happen? This is the denser medium and it is the rarer medium. So rarer medium is nothing but air. So refractive index of air is 1. So in place of mu 2, we have to substitute 1. So in place of mu 1, consider mu. So from that, mu sin C is equals to, refractive index of air is 1. So from this equation, sin C is equals to 1 by mu. So from that, C is equals to sin inverse of 1 by mu. So this is the relation between critical angle and refractive index. So what is the relation between critical angle and refractive index? So here the relation between critical angle and refractive index is C is equals to sine inverse of 1 by mu. So this is the relation between refractive index and critical angle. So here, okay. The next topic is applications of total internal reflection. So applications of total internal reflection, the best example is mirages. What is mirage? Suppose in summer days, suppose for example we are traveling into the bus. So then we have to observe that there is a water on the road. It will appear like that. When we go through that road, then what will happen? Layer by layer disappear. So here the mirage, the mirage is an optical illusion. The mirage is an optical illusion. Why? Because it will appears like that, but it not happen. So here, what is the mirage? Mirage is an optical illusion. It is one of the application of total internal reflection. So how the mirages are formed? Let us see. Suppose this is the surface of the earth. So this is the surface of the earth. So here in summer days, these are the air layers of the earth. Okay, these are the layers of the air. In summer days, the layer which is very close to the earth surface, it is too hot compared to upper layers. Compared to these layers. Suppose this is the surface of the earth. This is the surface of the earth. These are the air layers. So here, suppose for example sun. The light is coming from the sun. So here there is a tree. The light ray is incident on the object. Then what will happen? So this is the sun. The light ray is incident on the object. That object reflects that light. That object reflects that light. So here, that object reflects that light. Here, the air layer which is very close to that earth surface is too hot compared to upper surfaces. So it gets cool air. So whenever we go to that upper layers, it will be cool. So that's why it will act as a denser medium. It will act as a denser medium. So here that light ray, that reflected light travel from denser medium to rarer medium. So compared to this layer is cool compared to this layer. So that's why this is acts as a denser medium and it is acts as a rarer medium. So then what will happen? The refracted ray moves away from the normal. So this is the normal. So after that reflection. So here it gets internal reflection. Here there is an observer. We have to observe. Observe that light. So here reflected light. The light always chooses a straight line path. The light always chooses a straight line path. So that's why the object appears here. That is nothing but upright image. Upright image. And the reflection of clouds. Here we have to observe a water. So this is like this mirages are formed. So how the mirages are formed? This is the most important 4 marks question in our RPE exam. So mirage is an optical illusion. It is one of the application of total internal reflection. So here, whenever the sunlight is incident on that object reflects that light. The light travels from denser medium to rarer medium. Why? Because upper layers are cool compared to the layer which is very close to the depth surface. So that's why what will happen? The light ray travels from denser medium to rarer medium. The refracted ray moves away from the normal. Again it will happen, and we have to increase the angle of incidence. It gets internal reflection. Then we have to observe with our naked eye. But the light always chooses a straight line path. So that's why the object appears here, and the reflection of the clouds, it will appear water. So this is the formation of mirages.